Hello friends! After fitting the Gotek USB emulator, I had to do something about the scabby power cord. Instead of just replacing it, I decided to switch it to a modular IDC style power cord. I did not make a video of it because I am worried about someone electrocuting themselves and blaming me. Let's just say that if you have a flat piece of metal and can work it into a bend and drill and grind holes, it's not too difficult to convert your old equipment to something like this. The slot in the bottom cover will need to be widened, but I was planning to remove a dent and repaint it anyway. And now that the part that you cannot see looks better than the part that you can see, let's get on with the internal modifications. So now we've reached the point in this repair where we're going to switch out the LCD. The current LCD looks fine, it seems to work fine, however the inverter circuit is causing noise on the output. I'll insert some video here to demonstrate what you can hear. It's not good. It's like a high-pitched whine. I'll leave a link in the description to this new blue LCD replacement. It is not cheap. It's like 60 to 70 US dollars. But one of the tutorials mentioned putting a connector on here for the 20-pin ribbon cable, which is located here. And I was thinking, okay, yeah, that's a really good idea. I'd rather do that and then put actually make a ribbon cable and use it. However, he says to get a right angle ribbon cable, and it kind of looks to me like it's going in the wrong direction. It's sitting on a component, a resistor, a capacitor, I guess, and you're not able to, you know, and even if it was sitting down all the way, you wouldn't be able to really fit the connector in. So I don't know why he recommended getting this particular right angle connector. I mean, I'm pretty sure I have it oriented correctly. Pin 1 is here on this corner, and this connector has a triangle on it indicating that pin 1 is there. So it really looks like it goes this way. And he did say put it on the component side of it, which is this side. So the only two ways you'd be able to orient it would be this way, which you would think that's what he meant. But, and then when I was looking at the pictures, they really looked like he wasn't using a right angle one. He looks like he was using a regular one that sits like this. It's hard to see, but it's pretty sure I don't see a right angle. I think he decided that a right angle would be better without actually figuring out, you know, if that's the right thing to do. So because of that, because of my uncertainty about that, what I was going to do was I was going to maybe supply 3.5 volts to this this cable here for the backlight. It's the backlight that's here. Apparently, if you just take the 5-volt rail off the SY77, it's more than 3 volts. It's going to cause a problem. It's going to make the display too bright. The contrast circuit, which is also a DC supply into the board, into this LCD, which comes over the ribbon cable, is too high, but there's a resistor somewhere here that you can actually swap out, you know, get a larger value and bring that down. So I'll put some stuff on the screen that I came up with, that I made, some diagrams and stuff like that. And I'll also put links to diagrams. You can download, the diagrams that I'm using are the SY77 service manual, which is actually available. It's not the greatest scan in the world, but you can make out stuff. And from there I was able to look up the old model of LCD in the parts list. Well, the thing about the service manual on the SY77 is it is not down to the component level, it is only to the board level. So that means that, you know, it helps you diagnose problems. You can't order these boards from Yamaha anymore, and maybe at the time you'd have to be a Yamaha authorized, you know, dealer or technician or whatever. We're talking, you know, early 90s here. But it's kind of not so useful, but it can come in useful. It does include a block diagram, and it does include ways of diagnosing symptoms and what might be failing. And you can order, some people in Japan have parts that you can order if you're willing to pay that much for them. They're kind of expensive, and also to ship them all the way over. But anyway, so the service manual let me identify what the LCD model was. I was able to compare it to the new LCD, the pinouts and the voltages and everything. I was able to get the data sheet for the old LCD, and I was able to get the data sheet for the new LCD, and I was able to put them side by side and compare them on their pinouts and voltages and everything. And sure enough, although he didn't specify what the different voltages for the contrast circuit were, the contrast circuit on the SY77 for the built-in, this factory LCD is 13.9, and the contrast circuit for the new LCD is 12.9. So that's why he suggests putting a resistor there. And in his case, he uses variable resistors both for the contrast and the backlight. So anyway, hello cat. You're kind of in the way. Yeah, you're not helping. Not at all. So unfortunately, I was hoping, since I can access the connector without taking all this stuff apart, I was hoping to plug that thing in and give it a 5-volt supply. And it's okay if it's powered with the 13.9 for a little bit, just to see if everything's working okay. But I'm really going to have to figure out the orientation of the ribbon cable connector. Can I use a right angle connector? Is it, am I going to have to use a straight one? I'm going to have to wind up taking this apart enough to get to the LCD, at least to look at it. And unfortunately, that means removing everything, including this this board here and all these boards here, and everything's got to come out to get down to the LCD. So that's going to be fun. By the way, the service manual is good for also figuring out board removal and where the screws are and all that kind of thing, where the connectors go and all that. According to what some people say, you can't mess up the ribbon cables because every single one is a different pinout. So I can see that being a thing, definitely. Anyway, so I'm going to go ahead. There have been other tutorials on how to get. It's just screws and connectors, and just getting everything out. So I'm going to skip that part, and I'm just going to get to where the LCD is, and then I'll bring you back. All right, so I'm going to show you. Yeah, you can see that. So there is a notch on this top board for it. It's just that when that connector is going in its proper direction, it doesn't fit. But yeah. So if it was a straight up and down connector rather than a right angle one, so yeah, don't use a right angle header. Just use a straight header. The pins are correct and it works fine. Okay, just a note about the ribbon cables. First of all, I sell a ribbon cable crimper, but frankly, mine you don't need. You can buy any of those cheapo ones because the die that it has with it is fine for this purpose. My crimper includes dies for different sizes. So the one thing you need to remember when you're doing these crimpers, just as an aside, I've said this in my crimping tutorial video, you can always go look at that if you want, check my channel, is that you want to do these upside down when you first crimp them, because then you spin them 180 degrees and put the locking thing on the top. See, this one has the locking part and this one does not yet. It's going to be crimped down and then it gets its little locking thing, but when you do the locking thing, you have to spin the connector upside down to do it. So I was really careful about crimping this down on the cable like this, knowing that I was going to spin this 180 degrees and put the locking tab on. So I've done that. I've got this ready. It can go on here. Oops. Careful. And same thing here, we just need to make sure, so here's the orientation that we want on that. So we're going to spin this 180 degrees and put it on there and crimp it just like that.
So as I mentioned earlier, the white paper I found was for the SY99 and not the SY77. And the first difference is the location of the resistor you need to change for the display contrast. After some tracing, I discovered that for the SY77, the resistor we are looking for is R159, and it is located here.
Because R158 goes to ground, 0. So this has got to be the 1, this has got to be the minus 12 volts or whatever. Right now it's a 820 ohm. That was one thing that was left out of the original instructions, was what the current one, what its value was, and the pictures in it, it's hard to tell. Anyway, so we're going to switch that one out just like he did with R195. He did it with a potentiometer, but it already has a contrast adjustment. That's putting two pots in line. I don't really think that that's necessary. I think we can... He said that the way he left it was and he measured it after he installed it and tweaked it. He said that it was measuring at 2.4K, so that's what we're going to go for. So I think the LCD, the original LCD, connects to the I/O board right here. I just tried powering this up with just this plugged in, and I got nothing here. And I think that's because this is an isolated part of this. This is only a single-sided board. And this whole part is isolated. And it's got the output for the LCD, and it's got this coming from, what board is that called? Whatever board? Put it on the screen.
It's the DM1 board. This is the board we have been looking at with the LCD ribbon connector and the resistor we are going to change.
Anyway, so it comes from that board, and so I think this is where our 5 volts is. This is what the guy's talking about when he says, you know, there's a red and 2 whites, and the red is the 5 volts. So this section here kind of looks like an inverter to me. It's got a transformer and some capacitors. So that's the part that we do not want to power up. So we're going to replace this, and we're going to find a way to plug this in straight into that. This has got the wrong pitch of cable. None of the cables on this board, except maybe some power. This is like 2.54, and these are all 2, I think. So we're going to find a way to put a resistor in line and connect, and you know, we'll cut this one off. Or what's good is now I can put the rest of this back and then put that board in, and that board should power the connector here, and I should get my 5 volts that I want, and I'll measure that first. So let me put this all back together partially. There's our resistor. That's actually 2.2K. And this cable comes from the I/O board, and it plugs in here. So there is our, here's the connector we're concerned about. What is it, 118? And he said in his instructions it was CN33. So anyway, they're both in the same vicinity, which is convenient. So let me hook this board up and power it up and test for voltage on that connector. Yep, I just tested. The weird part is, from the way this is, I got the power off now. From the way this is oriented, the red one is not the power. The power is this white one on the end. Damn it. Yeah, 5 volts. Got nothing over here. And in the middle, you got nothing. So 5 volts on the front part of the connector, which is marked white. Isn't that weird? And the other ones, he said, were ground. Yeah. And according to there's a triangle here, pin 1. So pin 1 is red, it's a ground. Pin 2 is white, it's a ground. Pin 3 is white, it's the 5 volts. So we're going to cut this cable and splice in a resistor and then connect it to this cable. I guess we better verify that these colors are right too. Jeez. And just to verify, I've plugged this in here and I'm going to power it on. Hear that? It doesn't have an LCD hooked up to it, so the pitch is a little different. But there's our noise that we're trying to eliminate. So unplugging this, again, is going to solve that. And at the same time, we just need to step the voltage down from 5 volts to something less. Based upon the current characteristics of the new LCD, 80 milliamps, and the fact that we're going from 5 to 3.5 volts means that all I need is an 18 ohm resistor. He used a 78 ohm resistor, which basically means that it's running less bright, you know. And so maybe I'll pick that, maybe I'll go a little smaller. Either way, I'll make it so that I can change it if I'm not happy with it. But we're almost to the point where we can power this LCD up. Okay, there it is. I'm not happy with the contrast adjustment. I think I'm going to put a larger resistor in there, and we'll see what happens there.
Since I had this board out again, I decided to do a popular mod. Swap out the soldered-in battery with a removable CR2032 battery. There is actually nothing wrong with the old battery, but swapping it with a socket for the CR2032 lets you change the battery easily in the future.
All done. Pretty good viewing angle too. I went with a 4.7K resistor. The contrast at this point doesn't do a whole lot, so I guess I'm going to recommend a 3.3K, because I went from 2.2 all the way up to a 4.7, and it seems like right in the middle. But I mean, the 4.7 works great too, you know, because really you don't need to adjust the contrast. This isn't like certain LCDs where the contrast makes a huge amount of difference. The combination of the voltage being put into the backlight and the contrast setting I have it in now just makes it so it just works.
So here is an overall diagram of the LCD mod showing the final values for the resistors and how they are connected to the new LCD.
And no more of that whining sound coming out of the outputs once I disconnected the inverter for the old LCD. Anyway, thanks for watching, friends, and we'll see you next time.